This segment puts together what we've talked about so far and describes data types in full generality. We'll look at an example first of all. It's a data type with multiple constructors. It's a data type of shapes. So let's look at the definition. It says data shape, so it's saying we're defining the data type shape, and on the right hand side there are two options. Circle, constructor applied to a float, so a circle will contain or is built from a single float, which is the radius, and a rectangle is built from two floats, the height and the width. And so we've got those two different, and in the same data type we have two different kinds of data. We've got circles and rectangles. So a shape is either a circle or a rectangle. So examples are circle of 3.4 or rectangle applies 4.1 and 3.0. So both of those two different kinds of data live in the same data type. That's important too. Crucial to realize that. Now, how do we define a function, like the function to give the area of a shape? Well, we define it like this. We know that the two kinds of things that inhabit the data type are circles and rectangles. So we need to give an equation, we need to give a definition of what to do for a circle and what to do for a rectangle. And we distinguish between the two by having one equation using the circle pattern with a circle applied to R, the other saying what to do with a rectangle applied to H and W. So we're using pattern matching here. R and H and W are variables. So this said, the first equation says the area of a circle with radius R is pi R squared. And the second equation says the area of a rectangle with height H and width W is H times W. So those are just like the definition of what the area is of these particular geometric constructs. And you can imagine, as an exercise, I can leave it to you to define a function which gives the perimeter of a shape. You have to give the circumference of a circle or the perimeter of the rectangle, and you can define that by pattern matching. And also I could ask you to define a function that, when given a shape, will say whether it is round or not. So that will give the answer true on circles and false on rectangles. So those are two simple exercises for you to do just to check that you have a clear understanding of what's going on here. And here's another example which takes two shapes and tells us which one is smaller. And it says if we apply smaller to S1 and S2, then if the area of S1 is smaller than the area of S2, we return S1. So we return the one with the smaller area. And just to be clear, what's going on here is we're not using accessors and cases or anything like that. We're using pattern matching. So each equation covers one kind of shape. There are circle shapes and rectangle shapes. First equation covers circles, second covers rectangles, and each one names the components. So we use the variable R for the radius part of the circle. We use H and W for the height and width of the rectangle. And then those variables are used on the right hand side to define the answer, the result. So the area of a circle of radius R is pi R squared. And that is an equation that tells you what the area of a circle is. What's nice about it is it's a piece of Haskell code as well that you can execute. So pattern matching here is very powerful. We can distinguish between the cases, and we can access the components of something in an algebraic data type just using pattern matching. Now, another exercise is for you to extend the data type of shapes to include triangles. And I leave that to you. You'll need to add a new constructor for triangles. You might, depending on how you want to represent them. And then you will need to extend the functions for area and perimeter and is round to deal with a third kind of shape, namely a triangle. So you'll have a third equation for each of those three definitions. Again, that will help you consolidate your understanding of what's going on here. Let's look at what data types look like in general. What do they consist of? Well, I'm going to look at this example, but just generalize and explain what a general type definition will look like. It will have a type name. In the case here, it's a type shape. It will contain a number of options of different kinds of data. Each of those consists of a constructor, like rectangle, applied to a number of types. And those options are separated by a vertical bar. So particular examples of the type look like the constructor, rectangle, applied to values of those types. So we've got rectangle here applied to float and float in the definition of the data type. So a value will look like rectangle applied to two particular floating point numbers. Here 3.45 and 8.76. So we have a data type introduces a number of constructors, beginning with capital letters. Those constructors take arguments of particular types, which are described in the type definition, and then values of the type are constructed by applying the constructor to values of the types that the constructor expects to be applied to. So when you see rectangle, float, float in the definition of the type, you would expect to see rectangle 3.4, 8.7 in the data, for example. Now, one final exercise before we stop. I've shown you the type of shapes. We've got a circle of radius r, rectangle of height h and width w. These live in, they're disembodied. They don't inhabit any particular position, but you can imagine them being drawn on a plane. So you can imagine adding position information to these, the circle and the rectangle, representing the center of the circle and the center of the rectangle. So what I'd like you to do is do that. You'll need to change the definition of the data type shape. And then I'd like you to extend the functions perimeter and is round to this type. And I'd also like you to define two new functions, one that moves a shape by x comma y, as I've illustrated in the picture there. It moves it x along on the x-axis and y upwards on the y-axis. So that changes the center of the, changes the position of the shape. And an optional question is to decide whether or not two shapes overlap. That's a bit fiddly. It's relatively straightforward for circles and for rectangles, and when they mix, it's worth thinking about. If you want a little challenge, that will give you a challenge. But don't worry about doing it if you don't want to. You don't feel you want to do that. It's not a problem if you don't do it. Okay, so I think we've seen what in full generality a data type looks like. It's got a number of constructors. The type definition tells you the types of the arguments to the constructors, the data that's used to build the elements of the type, or conversely the data that's in the record, as it were, that builds a circle or builds a rectangle. And we've seen how to define functions over this this kind of data using pattern matching. It's a key part of the course. Haskell uses algebraic types all over the place. But there are a couple of other things to learn about algebraic types, which we'll do in two or three blocks time, to do with making them parametric and making them recursive. But for the moment, you've seen the general definition of algebraic data types.